Aliens, werewolves, mermaids. We all have something in common. We all love the moon. Who knows what life would be like without it? It sits so delicately in our sky, but it's got such a big impact on our daily and nightly lives. Did you know that it even helps birds make sure they're migrating to the right places? If we somehow lost the moon, or I don't know, if it somehow exploded on us, we'd be in so much trouble. But first, let's look at what would happen if it got closer. A little too close. What if the moon fell to Earth?
What if the moon suddenly began getting closer to Earth, to the point where it was on a collision course with our planet? Would Earth survive the crash? Or would a crash even happen? Would the moon get torn up by Earth's gravity? What would this crumbled up moon look like from Earth? This is What If, and here's what would happen if the moon fell to Earth. The moon is Earth's only natural satellite, and the largest object to brighten our night sky. It's the first and only place beyond Earth where humans have set foot. The moon's gravitational pull causes tides on Earth, tides that might have been the encouragement for life in our oceans to move on land. This pull also keeps Earth from wobbling on its axis, making our climate relatively stable. In short, the moon makes Earth a more livable place. So, what if it suddenly sped up and started driving in Earth's direction? The moon's plan to destroy Earth by bumping into it would break into pieces the moment it reaches the Roche limit. The moon itself would shatter, never making it to Earth's surface. And that's going to look very impressive. But wait, what is this Roche limit? In celestial mechanics, it's the point at which the gravity holding a satellite together is weaker than the tidal forces trying to pull it apart. In other words, the moon can only get as close as 18,470 kilometers away from our planet before boom, the tidal forces would tear it apart. All of the footprints and flags we've left on the moon, all of its craters and valleys would scatter to form a breathtaking ring of debris above Earth's equator, 37,000 kilometers in diameter, making Earth the second planet in the solar system, after Saturn, to have this striking ring of beauty. The difference being that our rings wouldn't last long. The chunks of our former satellite, the moon, would rain down on Earth. It would be as if hundreds of thousands of asteroids were falling down on us and wiping out entire cities in the process. Once the moon began its trajectory towards the planet, it would increase the tidal impact it has on us. By the time it hit the Roche limit, it would be causing tides as high as 7,600 meters. Our world would be devastated by an army of tsunamis, 10 times a day. But for a short time, hardcore surfers would enjoy riding some tasty waves. On the other hand, this might be a solution to global warming. With the moon coming closer and closer, Earth's rotation would speed up. Our days would become shorter and shorter, global temperatures would go down, and no one would worry about climate change anymore. Unless asteroids burned the Earth to a crisp, then there would be no one to worry about anything. I really wouldn't worry about it anyway. In fact, the moon is drifting away from us at a rate of 4 centimeters per year, so it's unlikely we'll get to see those pretty Saturn-like rings here on Earth.
Okay, this just in, we have an exclusive statement with a real-life Moonian. That's an alien from the moon. Ladies and gentlemen, give a warm welcome to Rose the Moonian.
Thanks, Peter. But you should know that the term Moonian is really offensive. We much prefer to be called Moon People. Anyway, I'm here today to teach you about my humble home. As you may know, the moon's surface is a little different than Earth's. We're covered in craters. These craters are caused by space rocks and comets striking our surface. That's because we have no atmosphere to protect us from them. They can be pretty scary. They sometimes even cause moonquakes. Yeah, we have those too. Living here isn't all that bad though. We're able to jump pretty high thanks to the low gravity, and we've got a gorgeous view of you guys down there on Earth. But what's all this I'm hearing about the moon exploding? We can't let that happen. Not on my watch.
What did you see that? Oh my god.
Is it a meteor shower? Space debris? No, it's something much, much worse. Our nearest neighbor is a full moon no more. The moon exploded and splintered into millions of fragments. Enormous lunar rocks are hurtling toward Earth. Could this wipe us off the face of the planet? How could the moon explode in the first place? And if we do survive, how would losing the moon change life as we know it? This is What If? And here's what would happen if the moon exploded. Okay, so how on earth did the moon blow up? A blast mining operation gone wrong? A nuclear blast? A collision with a rogue planet? Whatever caused this catastrophe, you'd have to be packing some serious firepower to blow up the moon.
Guns. Lots of guns.
The largest nuclear bomb ever built, the Tsar Bomba, had the energy of over 57 million tons of TNT. Think that's strong enough? It's just a drop in the ocean compared to the amount of force you'd need to blow up the moon. You'd need the power of over 600 billion Tsar Bombas to destroy the moon. With anything less than that, the moon would just crack into pieces, and its gravity would pull it back together again. But if someone, or something, managed to explode the moon, it would spell bad news for us. The moon debris would scatter across the solar system, some into the abyss of outer space, and some headed straight for Earth. Earth's gravitational pull would immediately start to attract the moon rocks. As the moon's remains start to pick up speed, they would come crashing down into the atmosphere. Luckily, most of the smaller debris would burn up before it reaches us. Any larger pieces that got through would be traveling much slower than a similar-sized asteroid. The damage they'd cause wouldn't amount to much. But is it just me, or is it getting a little hot in here? The moon chunks aren't causing much damage, but the endless barrage of debris on our atmosphere would start to heat up the Earth. The whole world would start to get hotter and hotter, eventually getting to the point of incinerating all life. Talk about a bad way to go. Oh, and if you're thinking about trying to evacuate Earth, you better do it as soon as possible. The moon debris, combined with all the satellites it would destroy in space, would make any trip out nearly impossible. But what if you did manage to get out of Dodge or hunker down in the deepest parts of the Earth? What would life be like in the aftermath? Well, for some of us, it wouldn't get any cooler. The moon helps stabilize the Earth's axial tilt. It's what gives us seasons. With a new tilt, some parts of the Earth could be constantly exposed to the sun. In the worst case, the polar regions could start rapidly melting, raising sea levels and drowning out parts of the world. As the debris settles, the skies could look a little different. The remaining moon rock might cluster around the Earth, forming a giant ring like Saturn. But don't stop and stare too long. Every once in a while, some of the debris could rain down onto the Earth. Over billions of years, the moon's gravitational pull slowed down the Earth's rotation, giving us our 24-hour days. Without the moon, the Earth would start to rotate faster and faster. We'd have shorter days and stronger winds. Birds and insects would have a tough time surviving the harsh winds. Not only that, ocean tides would start to die down into tiny little waves. The moon's gravity helps create tides on Earth. Bummed out that you can't rip some gnarly waves anymore? Well, dude, there'll be a much bigger problem. It would wipe out all of the sea creatures that rely on the tides and ocean currents for survival. Our whole world would be literally flipped upside down. The Earth would burn up. Our days would be shorter, and the moon wouldn't be there to light up the night sky.
Sorry about that, Rose. Can someone check to see if she's alright? Okay, so we know how insane life would be if the moon got closer to us and how terrifying it would be to watch it explode, but losing it is a whole other question. Don't get me wrong, I love the moon as much as the next guy, but would losing it be that bad? Hear me out. When the moon got closer to us, we had shorter days. So does that mean without the moon, we'd have daylight 24/7? If it does, I know I wouldn't mind that. Imagine getting home from school or work and having plenty of hours to hang out outside under the sun. And just wait until you find out why this would mean more time to party.
It's one small step for man, one giant leap for mankind.
Or one giant special effects budget. Can you believe that after 50 years, conspiracy theories about the moon landing are still in orbit? Roughly 6% of Americans believe the moon landing was faked, while another 5% are undecided. What do you think it would take to pull off such a hoax? How many people would have to keep quiet? And how much would it cost? This is What If, and here's what would need to happen to fake the moon landing. Lights, camera, action. July 16th, 1969, exterior, launch pad. Neil Armstrong, Buzz Aldrin, and Michael Collins board the Apollo 11 spacecraft bound for the moon. Across the world, 600 million people watch live as the three men are launched into space, land safely on the moon, plant the stars and stripes, and make it home safely. Come to think of it, that does sound a lot like Hollywood. But can you think of a studio with a $150 billion operating budget? In total, the Apollo program was allocated $24 billion to get to the moon, roughly 60% of NASA's budget at the time. That equals $150 billion in today's dollars. Assuming all that money went into pulling off the perfect hoax, how would they have spent it? Let's start with payroll. At the time, NASA had about 411,000 employees. An Oxford physicist, Dr. David Grimes, calculated that the secret might have had a chance to stay quiet for as long as 3 years and 8 months with that many people. So how do you keep 411,000 employees quiet about a fake moon landing mission for longer than 3 years? A bribe might be able to buy some silence. Today's NASA employees earn an average of $62,500. If you divide the Apollo budget in today's dollars amongst a workforce of 411,000 people, it comes to a payout of roughly $365,000 per person. Of course, employees would have had to accept much less, given the cost of the equipment and the production needed to fake a moon landing. You may have noticed that the shadows in the photographs of the moon landing appear to be parallel. Image forensics say these shadows accurately reflect the sun's position from 93 million miles away. Under conventional studio lighting, the shadows would appear more divergent, meaning NASA would have to step up their game in order to achieve a convincing look. To properly fake the sun's lighting in the 1960s would require a wall of millions of powerful laser lights so close together they'd be like pixels on a computer screen. Now consider that the $150 billion committed to the Apollo program was spent on 6 separate visits to the moon. So whatever the cost of the first conspiracy, bribes, equipment, etc., multiply that by 6. In 2009, NASA's Lunar Reconnaissance Orbiter sent back high-resolution photographs of each of the Apollo moon landing sites, showing boot marks left by astronauts. To fake these, NASA would have had to send something to the moon, like a robotic rover to make some tracks. The combined cost of the vehicle and the mission to put it on the moon would be roughly $68 million. Then another $504 million for a lunar orbiter to take the pictures. The bottom line of this prolonged spending spree is that the cost of faking a moon landing far outweighs the cost of doing it for real. Luckily, we're a species that puts its money where its mouth is, especially when we get curious.
You know, right now, it seems like everything is artificial. Your homework was done by a robot. You're eating microwave meals for dinner, and you probably know at least one person who could go easy on the lip fillers. But those are all small potatoes. Why haven't we reached for something bigger in the fake space? Like creating an artificial moon. We could make one so bright that we'd no longer need streetlights at night. I know we'd all feel a bit safer knowing it would never get completely dark. Now, I'm not sure if we could function with two moons, though. That could confuse some people. Not me. Maybe we just replace the real one. This one's tricky. I'll let you decide.
We can build really big things in space. Okay, not that big, yet. But we've packed the Earth's lower orbit with about 5,000 satellites. Some still functioning and some not. What if we could build a bigger, brighter satellite and put it into Earth's lower orbit? Something that would reflect so much sunlight that we'd never have to turn our lights on again. I'm talking about an artificial moon. How big could we possibly make it? And why would it be a bad idea to proceed with this space construction project?
This is What If? And here's what would happen if we created an artificial moon. The largest satellite we've put into lower orbit, the International Space Station, is as long as a football field. We assembled it in pieces in several launches, and now it's revolving around the Earth, some 400 kilometers above us. How would we launch an artificial moon that's 10 times bigger than that and position it high above the Earth's surface? Most of the Earth's satellites in low orbit are operating just above the ISS. Some of them are parked in geostationary orbit about 35,000 kilometers above the Earth's equator. The real moon revolves around us from a distance of 380,000 kilometers away. But we don't need to put our artificial moon that far away. We'd place it somewhere between the Earth and the ISS. That's a good spot right there. We'd have to make sure it maintains a speed of 27,400 kilometers per hour. Otherwise, it falls back to Earth. We'd cover its surface with some highly reflective material so that it could bounce the light from the sun back at us. Then, we'd turn off our lights and enjoy bright nights all year long. If you're not into falling asleep with the lights on, you'd need to get some very dark blinds for your bedroom. Too bad animals wouldn't have the same option. This new moon might cause havoc for nocturnal creatures who rely on moonlight to mate, hunt, or navigate. Too much light at night could mess around with your body too, leading to obesity and a higher chance of heart disease, diabetes, and depression. The artificial moon would also obscure the view of the natural sky. Ground-based telescopes wouldn't be able to capture images of deep space. It could result in us giving up on our dreams to go to distant stars, imprisoning us on Earth forever. So think about it. Do we really want this second moon? Well, wait for it. Some sources have reported that Chinese space engineers are already working on it. Their moon would be not just 10, but 80 times bigger than the ISS. It would shine 8 times brighter than the natural moon, and it would supposedly save them $173 million a year in electricity bills. However, we haven't seen the actual plans or a development strategy, so don't be upset if an artificial moon doesn't appear in the sky sometime soon.
So we here at What If are over the moon that you joined us today. On this show, we're always learning about space, history, and even what's going on in the animal world. Hey there, welcome to another exciting episode of What If? Today, it's all about the moon, the science of La Luna, the great celestial chunk of cheese that's inspired poets and astronomers for millennia. Yet, there are many secrets she's hiding from us here on Earth. From what powers drinking her water may grant, to the ways in which we can harness the solar activity she reflects, to maybe the greatest mystery of all, is the moon actually flat? Well, for a deeper appreciation of our only moon, let's take a quick look at life on Earth if she wasn't around anymore.
The moon is a giant rock that lights up our night and can even change colors. So what would we do without it? Would we all need night vision goggles? How would it affect the ocean tides, our seasons, or our sleep cycles? Or would the consequences be far more dramatic? This is What If, and here's what would happen if we suddenly had no moon. As the closest celestial body to our planet, the moon exerts a gravitational pull that governs much of what happens here on Earth. Take the sea, for example. If you like surfing, you can thank the moon. When the moon's gravitational pull tugs on our spinning Earth, the oceans respond, giving us high tides in some parts of the world and low tides elsewhere. And while the wind gives the waves their energy, tides define their shape. The moon's gravitational attraction also keeps us at a stable 23.5-degree tilt relative to the sun, giving us 4 seasons and a livable climate. But what if that livable climate were to suddenly become unlivable? With the moon gone, its stabilizing effect on the Earth's rotation would go with it. Want the good news first? The weekend just got a whole lot closer. If the moon suddenly disappeared, a day on Earth would only be 6 to 8 hours long. Over millions of years, shifting tides and their pressure on the Earth's continents have slowed our planet's rotation, giving us 24-hour days. But without the moon's strong gravitational influence, the world would spin 3 to 4 times faster than it does now. Here comes the bad news. Rotating at that speed, we would experience winds up to 480 kilometers per hour. Birds and insects would have no chance of survival. The luckiest land-based organisms would either be deeply rooted plants or very short, very stout animals. Most of our marine life would be wiped out, since sea creatures that rely on ocean currents for survival would lose the privilege of the ocean's pull. Currents help circulate vital nutrients from the ocean floor to the surface, while dragging oxygen-rich surface water deep into the sea. We'd still have tides, but now they'd be governed by the sun, and from a distance of 93 million miles away, they'd only be 1/3 as powerful. And with the moon suddenly out of the way, the oceans would rip towards the sun, causing catastrophic waves, killing thousands and submerging coastlines. At this point, we'd have to adjust to new ocean currents, which, circulating at a slower rate, would be heating up equatorial waters while turning polar waters frigid. These extreme differences would produce a similar effect on land as well, since ocean temperatures influence their regional climates. Along with the sun, Mars and other nearby planets could also claim a share of gravitational influence over our planet, pulling Earth in different directions and causing it to tilt with increased volatility. Earth's axial plane would vary some 10 degrees, causing dramatic shifts in seasons and rendering our climate uninhabitable. Most crops would die with the drastic temperature changes. We'd experience the worst ice ages known to man, as huge glaciers from the North and South Poles would encroach upon the Earth, covering everything except perhaps a small band across the equator. So while full moons may attract werewolves, that's still better than an alternative world where the moon doesn't exist. The next time you look up at the sky, be glad it's there. Sleep soundly tonight, surf's up in the morning.
Yeah, I'm glad we have that big beautiful rock floating in our night sky. Knowing all the incredible ways the moon helps keep life as we know it in balance, well, it got me thinking. Is there a way to squeeze even more benefits out of it? Think about this. What if we covered the entire moon with solar panels to create a jackpot of renewable energy? Imagine the moon lighting up the night sky like a giant disco ball, reflecting light from the sun and generating power. Just how much energy could a solar panel covered moon supply? And how many panels would it take to transform it into a true powerhouse? Oh, and is there any way to make this disco ball moon happen in our lifetime? Not too far from Earth is a giant space rock that has silently played host to just 12 people in its entire history. What would happen if we put our cosmic satellite to work by covering it with solar panels? What would it take to build an enormous power plant on the moon? How big would this facility be? And how much time would it take to finish this mega construction? This is What If, and here's what would happen if we covered the moon with solar panels. Because the moon has little to no atmosphere, there's no wind, no rain, and no clouds on that space rock. If a lunar weatherman were to tell you the forecast, it would always be the same.
Once again today, you're looking at a daytime high of 130 degrees and sunny, sunny, sunny.
Imagine how much energy we'd collect from a place where the sun never stops shining. But how would we even build a solar plant on the moon? One Japanese company, Shimizu, already has that covered. They want to build a so-called Luna ring. And yes, it would look just the way it sounds. A ring of solar panels spanning around the moon. The construction would stretch for 11,000 kilometers along the moon's equator and would reach 400 kilometers in width. That's enough to cover half of the United States. Where on Earth would we even find enough materials for assembling this enormous solar plant? Well, the answer lies outside of our planet's natural budget. Most of the building materials would come from the moon itself. We'd only have to launch the initial equipment over there, just enough to start building more equipment and manufacturing lunar robots. Then a team of robots, together with a group of astronauts, would handle the rest. For starters, they'd construct huge excavator and ore processing machines to mine the moon. Then, they'd begin assembling solar panels from the lunar materials. With nothing but lunar soil and gravel, they'd make concrete, ceramics, and solar cells. Meanwhile, astronauts on Earth would be working on building spaceports in low Earth's orbit to ship the remaining supplies, like hydrogen, to the moon. Even with the most advanced technology we can think of, the construction would take at least 2 generations of humans to complete. But once it's done, we'd have a super efficient lunar power plant, churning out power 24/7. Because there are no bad weather days on the moon, ever. But what about getting that power back to Earth? Well, that's the fun part. On the moon, the lunar power plant would transmit solar power to the energy converting facilities. From there, the converted power would be beamed to power collecting stations on Earth with lasers and microwaves. How cool is that? Potentially, it could deliver so much energy that we wouldn't need any other power sources at all.
Now, while gathering power from the moon sounds like an exciting possibility in the future, moon water might offer some unique benefits to us right now. But wait a minute, what's actually in moon water? Besides fractaled rainbows and stardust. Maybe the moon's water is made up of the same chemicals found down here on Earth. Or maybe it contains cosmic dusts, trace elements from meteorite impacts, or something entirely alien. Let me show you what happens if you take a big, bold sip of moon water.
Would you drink water that was extracted from the moon? With NASA's recent discovery of water on the moon's surface, it might become more of a common practice. And even though it won't look as cool as this, it would still be a lot different than what you're used to drinking. How would it taste? What effects would it have on your body? And why is it so crucial for the future of space exploration? This is What If, and here's what would happen if you drank a glass of moon water. I know what you might be thinking. Wait, didn't we already find water on the moon? And you're right, we did, but before, we only knew that it was hiding in the shadowy craters of the moon's poles. Now we've discovered that there's even more water distributed across the moon's surface. This water is very important because it could one day form the basis of a lunar settlement and economy. So now the question is, how do we get this water out of the moon? And is it safe to drink? It shouldn't come as a big surprise that the moon has significantly less water than the Earth. 1 cubic meter of soil spread across the lunar surface contains only about 0.1 to 0.4 liters of water. That's about the same as a 330 milliliter water bottle. Even the Sahara Desert has about 100 times more water than this. The good news is, this moon water should be relatively easy to extract. You don't need to drill deep into the surface for that type of water. But the bad news is that it would be very expensive. It's estimated that water could be mined and processed on the moon for about $500,000 per ton. That means that the amount of water needed for a shower would cost $39,000. And the cost of drinking water for one person for one day would be about $2,000. As expensive as this all sounds, it would cost about 20 times more to ship water up from Earth. So if you're ever lucky enough to be up on a lunar base, moon water is likely what you'd be drinking. A glass of moon water would probably taste like salty, hard water that we have here on Earth because of what's inside it. Moon water may contain metallic elements like mercury, magnesium, and sodium. And each of these elements could cause some serious issues for you. First off, there's mercury. Smaller amounts of mercury can be found in several food sources and may not affect your health, but consistently larger doses can be dangerous. Mercury poisoning is linked to cognitive issues, with symptoms closely resembling those of Alzheimer's and dementia. Then there's magnesium. It's often a prime ingredient in laxatives, which might give you some idea of where this could lead. It's up to the kidneys to flush out the magnesium your body doesn't need. Still, if your system is flooded with it, you could experience symptoms such as vomiting, diarrhea, and, in extreme cases, cardiac arrest. And just in case that doesn't sound enticing enough, the moon water could also contain high sodium levels. That could lead to high blood pressure and cardiovascular issues since you'd be drinking this water every day. But, let's be real here. If we have the technology to get ourselves to the moon and mine water from it, then surely we can develop technology to filter that water too.
Okay, strap up, folks. You've heard me talk about a flat Earth. You've heard me talk about having no moon. Well, prepare yourself and take a seat if you're not already sitting down, because I may have found the ultimate what-if scenario. Yeah, one that could change science as we know it. What if the moon was flat? I will not elaborate.
No, that's not Photoshop. That's an actual video from the International Space Station of the moon looking a bit squished. Wow. So, what happened here? Is the cover-up behind a flat moon an elaborate government conspiracy? How would this affect the oceans? What would happen to our climate? And could the moon fly out into space? This is What If, and here's what would happen if the moon was flat. In 2010, an astronaut on the International Space Station observed a bizarre phenomenon. When he glanced out the window, he saw the moon looked flattened when it appeared in the thickest part of the Earth's atmosphere. And those of you in the Flat Earth Society, don't at me, it's not flat. High above the planet, the air bends light to give the moon this squished look in these very specific conditions. But if the moon were flat, it would explain why we never see the mysterious dark side. And if this was our reality, how would this affect gravity on Earth? Okay, there are no illusions this time. The moon is flat. So, how would that happen? Well, a celestial body would need to spin incredibly fast to become a flat disk. So fast that it would rip into tiny pieces before it would ever have a chance to form. For our purposes, let's say the moon survived this process and formed like a plate. Would this flat moon have the same mass as what we see right now?
Well, as a flat disk, the moon could have 25% of the thickness, but the width might remain the same. With so much less mass floating above the Earth, the change in ocean tides could be the first noticeable effect. The moon's gravitational pull generates these tides. Our moon pulls the water on the side of the Earth that's closest to it, but this flat moon would have less mass and less gravitational effect on our planet. And the altered tides would affect more than just surfers. Ocean tides stir up material below the water's surface, allowing coastal ecosystems to thrive. Without the usual strong waves, animal life in the oceans, like crabs, mussels, and snails, could die off in mass numbers. This chain reaction could decimate life worldwide. And that's not all a flat moon would ruin. Remember, the tides also push water back and forth around the planet. When warm waters travel from one area to another, these tidal forces change weather patterns globally. Without the strong tides, we could experience extreme temperature changes. But even with all these devastating changes, the climate still wouldn't change as fast as the days. The moon's mass influences our planet's rotation, giving us a 24-hour day. But with a flat moon, the day could be only 15 hours long. But I think most of us could live with a 5-hour workday. And while we'd get more sunlight, the nights would be even darker. You see, the moon reflects the sunlight to give off that bright glow we all know and love. A smaller moon would reflect less light, making it much dimmer. That would make it harder for nocturnal animals that rely on the moon for navigation and hunting. But maybe none of that would matter since it could potentially crash right into us. Wait, what? Yeah, the Earth and the moon are locked together in an eternal dance. The motion created by one affects the other. I know, this sounds hippy-dippy, but trust me, we're talking science here. The same tidal forces that move the oceans also affect the moon's orbit. The tidal bulges in the ocean rotate faster than the moon orbits the Earth, and this rotation takes energy away from the Earth and transfers that into the moon's orbit. This is called tidal friction and causes the moon to drift away from us at the rate of 3.82 centimeters every year. A flat moon with less mass would orbit closer to our planet. So maybe it wouldn't slam into Earth, but our view of celestial phenomena wouldn't be the same. Right now, the sun and moon are positioned just perfectly that when aligned, we get a spectacular image of a total eclipse on Earth. The moon covers the sun entirely in this breathtaking event. A squished moon wouldn't be able to block out the sun entirely during an eclipse, and we would see the top and bottom of the sun peeking out. A flat moon could destroy the balance of life on Earth and threatens every ecosystem and living organism, including humans. The great thing about this show is being able to explore all these scientific theories. Now, while the moon probably isn't flat, it's definitely made of cheese. I mean, millions of kids around the world can't all be wrong. Out in the vastness of space, it's not just stars twinkling calmly. No, things are happening. Things are moving. Orbits, crashes, explosions. It's almost like the universe is hosting the ultimate cosmic dance party. Whether it's asteroids crashing against spacecraft in a tango or Jupiter doing the samba with the black hole, these celestial bodies move and shake, and they have quite an effect on us from millions of kilometers away. But hey, don't just take my word for it. Let's dive in and see for ourselves. To start off this intergalactic shakedown, let's take you deep into our solar system and start by boogieing along with Saturn's dazzling rings.
Since its discovery in 1610 by Galileo, the rings of Saturn have enchanted us for centuries. Remarkably, we've visited Saturn before. Stunning photographs taken from the Cassini space probe have revealed that Saturn's rings are much more complex than you might think. So, what would it be like to actually go in person? How long would it take you to travel to Saturn? What would you see along the way? And could you survive in Saturn's rings? This is What If, and here's what would happen if you jumped into Saturn's rings. On October 15th, 1997, NASA, the European Space Agency, and the Italian Space Agency banded together to change the history of astronomy. Their mission was to study the Saturn system, a diverse mix of stellar objects made up of rocks, ice, and several moons. Together, they developed the space probe Cassini-Huygens, which was propelled on a 7-year journey to Saturn. Let's imagine we had the technology to bring you, traveler, along for the ride. What kind of adventure are you in for? Well, luckily, we're taking the scenic route. After a year of drifting through space and saying goodbye to Earth, our first stop is Venus. Don't worry, this isn't a layover. We're merely visiting the outer edge of Venus's orbit, giving you a gravitational speed boost as you pass by. This will allow you to save on fuel and take in the view of Venus's swirling scenery. After the first orbit, you'll get a nice boost of 7 kilometers per second. But we'll need one more journey around it for the optimal speed boost. This time, we'll be about 600 kilometers from Venus. I hope you have a strong stomach, traveler, as the gravitational pull might be like that time you ate funnel cake before going on that spinny ride at the fair. Oh, never again. After a quick spin around Venus, you'll be slingshotted towards Mars and Jupiter, but this part of the ride might get a little bumpy, so buckle up. You're about to pass through an asteroid belt. Fortunately, the chances of hitting an asteroid are pretty slim, as they are very spread apart, unlike what you see in the movies. Still, you never know. Just be prepared to take manual control in case your proximity sensors malfunction. Once you've made it through the scary part, it's fairly smooth sailing from here on out. Sit back and admire the view. On your right, in the distance, you'll see the red planet Mars. And on your left is Jupiter. Look! That tiny speck orbiting the gas giant is the Galileo spacecraft. A small yet welcome reminder of home. At this point, it's been almost 5 years. Wow, how time flies when you're being hurled through space. Saturn is our next stop. But is it safe? We're about to find out. After waiting a couple of years, doing lots of Sudoku, and rewatching all your favorite What If videos, we've finally arrived in orbit of Saturn. Surprisingly, the flat and solid ring structure you've seen in pictures back home were way off. These rings are complex systems of orbits subdivided by several different sections. Each of these rings are separated by gaps made from over 60 of Saturn's moons. The rings are made up of chunks of ice and rock, some as small as little boulders and some as big as houses. These are the remnants of comets, asteroids, meteoroids, and shattered moons torn apart by Saturn's gravity. All right, traveler, it's time for a spacewalk. You probably won't have much success walking on Saturn's rings unless you happen to land on one of its moons, like Metheny, Pallene, or even Titan, which has been considered a potential site for a future space colony. But you'll want to keep your spacesuit on, as Titan is a chilly minus 179.6 degrees Celsius. At this point, you're almost twice the distance between the Earth and the Sun. Now for the moment of truth. The grand finale. As we approach the final rings of Saturn, we'll have to fly through them on a careful trajectory, orbiting Saturn 22 times to get our best travel shots. Here, you'd be only 2,000 kilometers away from Saturn's atmosphere. After about 20 years in space, you'd reach Saturn's interior. Let's be honest, you'd likely disintegrate, but thankfully, you were careful and managed to hang around on Titan instead, leaving the Cassini probe to do the rest of the work. The amount of data Cassini managed to send back to Earth is truly spellbinding, making it one of humankind's greatest success stories in astronomy. Maybe on our next voyage, we could take a closer look at Saturn's big brother, Jupiter.
All right, now we've got this party started. While Saturn is definitely a spectacle in the night sky with its fabulous rings, it's not our biggest planet. That title goes to Jupiter, which weighs in 3.3 times the mass of Saturn. During our cosmic dance tonight, we're bound to see a few bodies bumping into each other and stirring up some drama. What would happen when the unstoppable force meets the immovable object? If that immovable object is Jupiter, weighing in at a staggering 1.9 quintillion tons, what would be a fair unstoppable force? A black hole. This is what if, after all. It's going to be a black hole. Let's see what happens when these two astronomical objects challenge each other to a dance fight. It's time for one of the biggest battles our solar system has ever seen. In this corner, a gas giant and heavyweight Jupiter. And in this corner, an infinitely small but truly terrifying black hole. What would happen to these rivals as they hurtled toward each other? Why would this event cause Earth to be bombarded by asteroids? And would it be game over for our solar system? This is What If, and here's what would happen if Jupiter collided with a black hole. Okay, before the fight, let's take a quick look at exactly what each contender is up against. Starting with our solar system's favorite. Jupiter is the 5th planet from the Sun, located about 740 million kilometers from it. This gas giant is the largest planet too. It's about 318 times more massive than Earth and twice as massive as all the other planets in our neighborhood combined. But looks can be deceiving. Compared to its opponent, the heavyweight Jupiter isn't all that heavy. Stellar black holes are a lot smaller than our gas giant, but they sure can pack a punch. The thing about black holes is that they are dense, incredibly dense. All of their matter is contained within an infinitely small point known as a singularity. And inside this tiny region, all concepts of time and space fall apart. And like any object with mass, black holes have gravity. A lot of gravity. Most black holes are remnants of massive stars. They're called stellar black holes, and they range from 3 to 10 solar masses. But because they're so dense, if a black hole with 10 times the mass of our Sun appeared in our solar system, it would only be 60 kilometers across. So, would our gas giant Jupiter stand a chance to defeat its tiny but immensely powerful contender? Or would it just be another object lost inside the black hole's point of no return? Everything in the universe is moving through space at breakneck speed, and naturally, that includes the sun and the rest of our solar system. We're whizzing across the cosmos at about 720,000 kilometers an hour. And in this galactic dance, another star may come close enough to us to influence the outer regions of our solar system. Or worse, we might run into one of the nearly 1 billion black holes rampaging around the Milky Way galaxy. Of course, the chances of this happening are slim. The closest star in our neighborhood is over 4 light years away, and that's far. Scientists think that there's only a 1% chance that another star will ever come close enough to disrupt the edges of our solar system. The chances of a rogue star coming close enough to mess with Jupiter are even lower. But it could happen. At first, as this stealthy force of destruction swung toward us, the black hole would disrupt the Oort cloud. This area surrounds our solar system like a giant spherical shell, and it's filled with icy objects. But these mountain-sized ice cubes would be no match for a black hole. As they were pulled along for the ride with this small but massive monstrosity, this would be the first sign that an epic collision with Jupiter was unavoidable. The gravitational intruder would continue through the next region, the Kuiper Belt, and it would wreak havoc along the way. Many of the icy objects here, including the dwarf planet Pluto, would be ejected from their orbits. Things would suddenly get more serious for Earth, as many of these objects would now be on a deadly collision course with us. As it passed Neptune, Uranus, and Saturn, the black hole would tear away their gases. These gases would form an accretion disk of superheated gas and dust around the gravitational intruder. And if the black hole came too close to any of these planets, they could also be at risk of being ejected from their orbits. Then, the black hole would finally bear down on Jupiter. And right away, the gas giant would experience a similar attack on its atmosphere. The black hole would pull away hydrogen and helium gases like yarn from a yarn ball. Eventually, the entire planet would be pulled toward the black hole. It would be an unfair fight from the get-go. Jupiter wouldn't even be able to get a punch in, and if all this isn't violent enough, just wait. As this dense and hungry monster chowed down on Jupiter's abundance of gas, it would also release an explosive wave of UV and X-rays in all directions. Yeah, it would be like one big supermassive burp packed with deadly radiation. This radiation would hurtle toward us on Earth. In less than an hour, lethal amounts of radioactive material would rain down on us. But on the bright side, you'd finally be able to see the black hole up in the sky. Whatever stability we enjoy in our solar system would be gone. The black hole would be swallowing up everything in sight, including our planet. Now, if we somehow managed to be spared the full brunt of the black hole's destructive forces, well, without Jupiter, our solar system would need to find a new gravitational balance. Yeah, Jupiter had a special place in our neighborhood. Its enormous gravity kept asteroids and comets from pummeling us and other inner planets of our neighborhood. It also helped Earth maintain its nearly circular orbit around the Sun. So even if we survived all the gravitational havoc from a rogue black hole, without Jupiter, this little space rock we call home wouldn't last long. But hey, let's not kid ourselves. What are the chances this black hole would devour Jupiter and then just stop dead in its tracks? No, it's coming for you too. You'd get a first-hand look at what would happen if a black hole sucked you into its event horizon. hopefully you can travel faster than the speed of light. Otherwise, your annihilation would be horrifying. Speaking of eclipsing events, there's nothing quite like dancing under the glow of a full moon. But you know what would take your backyard party to the next level? A disco ball the size of the moon. Imagine it, every beam of sunlight bouncing off a million tiny mirrors, turning Earth into the ultimate intergalactic dance floor. While the moon reflects about 13% of the sunlight that hits it, a disco ball reflects significantly more. Concentrate all that energy into a single point, and you might just turn this dance party into a cookout. Let's spin that idea around and check it out. Someone replaced our moon with a disco ball. How could you turn the moon into a classic disco ball? How much more light would this new moon reflect? And would it actually turn the Earth into one giant nightclub? This is What If, and here's what would happen if we replaced our moon with a disco ball. You know, no matter how bright it seems, the moon doesn't produce any light of its own. Instead, it gets its shine reflecting about 10% of the incoming sunlight that hits it. And thanks to the uneven surface of the moon, that light is reflected at many different angles. If we made the moon more like a disco ball, we could change the way it reflects light entirely. Disco balls cast dazzling beams of light all over a room. They do that thanks to their many mirrored tiles. Now, imagine a disco ball the size of our moon in our night sky. Would it spark an amazing rave back on Earth? Or would it literally ignite fires? Okay, where would you even start? Knocking the moon out of its orbit and placing a giant disco ball in its place could be quite problematic. So, you could start with something a little less dramatic, like covering the moon in mirror tiles. A disco ball has a radius of anywhere between 10 to 183 centimeters. The moon, however, is bigger, much bigger. It has a radius of about 1,700 kilometers. Making a disco ball that large would require covering the moon's surface with over 3,000 mirror tiles. And those wouldn't be your average dressing room mirrors. These massive tiles would range in size from 100 to 150 kilometers across. You'd have to create those giant mirrors on Earth and then deliver them all the way to the moon. It would take you at least 3 days to get them there, and it's gonna take a few round trips. So it might be a good idea to ask NASA or maybe the SpaceX team to help out with robotic lunar missions while you'd be preparing for the party of your lifetime. Okay, now that all the mirror panels are in place, wait, where did the moon go? As anticlimactic as it sounds, once you turned the moon into our solar system's own disco ball, you wouldn't see much from Earth. The moon reflects so much sunlight because the lunar surface is so uneven. This makes light bounce off in a chaotic manner. The sunlight hits the moon at one angle and then is scattered at different angles. But now that the disco moon would have a very even surface, the sunlight would get reflected at the same angle it came in. You'd have to try very hard to see this new variety of reflected moonlight from Earth.
Well, what is that?
Now, you'd need to find yourself at the exact angle of the reflection.
Is anyone else seeing this? That's it!
Based on the locations of the Earth, Sun, and Moon, these reflections would only hit the Earth every few months. What you'd witness would be more like an extremely brief flash of light in the sky. Not quite the funky global ambiance you had in mind. Okay, well, maybe you could take things up a notch with a little creative engineering. Yeah, instead of flat mirror tiles, you could use curved mirrors. These would reflect all the incoming light into one point. This would certainly increase the likelihood of the reflected light reaching you back on Earth, but it would come at a pretty grave cost. All that energy concentrated into a single point could create a sunbeam strong enough that it would cause havoc wherever it hits. This could turn the moon into a Death Star-like device of destruction. Except in this case, multiple beams of light would wander over different parts of the planet. Anything in their path would ignite in flames, leaving behind nothing but patches of scarred Earth. It's the same effect as if you concentrated sunlight with a magnifying glass, only about 1,000,000 times worse. Now, if the moon were no longer tidally locked, there would at least be the upside of having reflections that could move fast enough across the Earth's surface to avoid igniting everything. Now, despite the chaos of hyper-blazing sunbeams, you'd be lucky that the mirrors don't reflect an enormous amount of UV radiation toward Earth, enough that it may burn you to a crisp. Maybe the trick to getting the party started would be to supply the disco ball moon with some artificial light from here on Earth. For this, you could try beaming lasers at the moon. Sure, this light could reach the moon, but the odds of being able to see any of it reflected back to Earth would be slim to none. As the laser beam traveled through Earth's atmosphere, photons would scatter in many directions. The chance that photons of light launched from Earth would reach one of the moon's reflector panels would only be 1 in 25 million. And then, those photons would need to make the uninterrupted journey back through our atmosphere. The probability of that happening would be an even more dismal 1 in 250 million. Now that you're desperate for something to impress people with, you'd go to your last-ditch effort, wrapping the entire moon in aluminum foil. If you managed to do this smoothly, you could make the moon around 8 times brighter than it is today. I mean, it still may not have the dazzling effect you were hoping for from the get-go, but if you crinkled that aluminum foil up a bit, you could get a few small reflective glints, like bouncing off a glass or a watch. We're sorry that the party really never kicked off the way you wanted it to, but if you really managed to cover the moon in mirrors, you'd at least be treated to a truly stunning sight. It would almost be like catching sight of a second Earth in our own solar system.
So there you have it, folks, the conclusion to our cosmic dance party. We danced beneath Saturn's rings, watched Jupiter and a black hole do the tango, and even got to experiment with a true full moon disco. I think I prefer my dance parties to feature significantly more ABBA and significantly fewer gas giants. Maybe we should get rid of all the other planets, leaving Earth alone with the sun. But that's a story for another What If.
Humans, werewolves, mermaids. We all have something in common. We all love the moon. Who knows what life would be like without it? It sits so delicately in our sky, but it's got such a big impact on our daily and nightly lives. Did you know that it even helps birds make sure they're migrating to the right places? If we somehow lost the moon, or I don't know, if it somehow exploded,